A shipping container can be more than 12 meters long, weigh nearly 4 tons, and offer only about 28 square meters of usable interior space. Yet this narrow steel box is now being transformed into a modern home. Containers were originally designed to protect cargo with long, enclosed steel interiors, but moisture can build up inside, causing rust and mold. More importantly, cutting large openings into the walls can weaken the steel structure that keeps the entire container stable. To control these risks, each container must be carefully reinforced and properly treated before it can be used as a living space. So, what steps must these ocean-traveling cargo boxes go through before they can become spacious, durable, and fully equipped homes? Join Mandarin Tech as we break down the entire construction process in today's video. The construction process begins before the first container even arrives at the site. Once the container locations are marked, bulldozers level the ground. The crew then excavates the area for a solid concrete slab foundation. Wooden boards are used to form the edges of the foundation and are held in place with steel stakes. Inside the formwork, 6-meter-long steel bars are cut, positioned, and tied together according to the structural engineer's drawings, creating a large reinforcement frame. Underneath, a moisture barrier, clean sand, and small concrete blocks are added to keep the steel reinforcement raised above the bottom. The drainage system was originally planned to run directly through the concrete slab. However, because it was difficult to line up the pipes exactly with the container floor, the crew decided to place only the main drain through the concrete. The remaining pipes would later be installed inside the house floor. After the construction permit was approved, 6 trucks delivered more than 40 cubic meters of concrete to the site. The concrete was pumped directly into the foundation form, then leveled and finished. Control joints were also added to reduce cracking as the concrete expands and contracts. As the concrete began to set, the crew kept the surface continuously moist so it could reach the required strength. A few days later, the wooden formwork was removed, and all utility openings were checked one final time to make sure they matched the construction drawings. Once the foundation is strong enough, the shipping containers are delivered to the site and carefully lifted by crane onto the concrete slab according to the building plan. First, the positions of the windows and doors are measured and marked. The openings are then cut using an angle grinder. Because much of a container's strength comes from its continuous, corrugated steel walls, every opening must be reinforced immediately after cutting. Once an opening is made, the paint around the cut edges is removed to expose the bare steel. A steel frame is then placed inside, leveled and tack welded in sections about 75 millimeters long, spaced roughly 200 millimeters apart. Continuous welding is avoided because too much heat can cause the thin container walls to warp. For some rear doors, angle steel is used to create overlapping door panels. This makes alignment easier and also allows sealing on both the inside and outside. Inside the container, a timber frame is built according to the engineer's drawings. Vertical studs are installed around doors, plumbing lines, and other load-bearing areas. Above large openings, headers are added to prevent the structure from sagging and causing the door or window frames to jam or deform. The bottom plates are fixed directly to the container's plywood floor. At the top, double plates, galvanized steel brackets, and self-drilling screws connect the timber framing to the steel beams running along the roof. Horizontal timber blocks are also added to provide solid fixing points for plywood, drywall, and ceiling panels. Some shear walls are anchored directly to the concrete foundation. Steel rods are drilled through the container floor and fixed into the concrete with epoxy before being connected to the timber studs. This ties the container, the internal frame, and the foundation together as one structural system, helping the house resist sideways forces and vibrations. Once the structural frame is stable, the empty steel openings in the container walls are filled with doors and windows. The biggest feature is a pair of folding glass doors installed opposite each other, creating a wide opening straight through the house. When all the door panels are folded to the sides, the living room almost becomes part of the outdoor space. But every square meter of glass adds cost and requires more of the container's steel wall to be removed, which means extra reinforcement is needed. The door frames are placed on 25 millimeter thick timber supports and carefully leveled before being screwed into the internal framing. Any gaps between the steel container frame and the door frame are then filled with fire-resistant expanding foam, trimmed flat and covered with steel angles and flat steel plates. Above the doors, 3 mm thick steel plates are welded together to form small sloped canopies. These add depth to the exterior, reduce direct sunlight on the glass, and guide rainwater away from the door frames. The welding is done in short sections to prevent heat from warping the container's thin steel walls. Once the doors and windows are fully sealed, the crew begins installing insulation. Thick, rigid foam boards are cut to fit between the timber studs. Spray foam is then used to fill smaller gaps around the container corners, electrical boxes, and plumbing lines, helping prevent hot air from entering the interior. Once the structural frame and insulation are complete, the containers still are not ready to function as a real home. The next stage is connecting the entire building to electricity, water, drainage, and temperature control systems. The house is located about 20 meters from the nearest power pole. From there, an electrical conduit is buried nearly 1.2 meters underground and runs directly to the main electrical panel mounted on the outside of the container. Because the concrete foundation extends beyond the steel walls, the crew has to cut and break a small channel into the slab. This allows the conduit to make a 90-degree turn and run close to the electrical panel. Other underground conduits connect the containers, supply power to the septic pump, and link the backup battery system. Instead of operating completely off-grid, the house is connected to the main power grid and uses a Goal Zero battery as backup power. During an outage, the system can keep the refrigerator, Wi-Fi, lights, and several essential circuits running. 3 100-watt solar panels can also be installed on the roof to charge power tools and electric motorcycles, allowing the battery system to be used every day. The water system is simpler. From the water meter, PVC pipes are buried underground and run toward the house. Near ground level, they connect to copper pipes. One branch supplies an outdoor faucet, while another carries water into the containers. From there, hot water lines are routed to the kitchen, bathrooms, and washing machine. The final system is heating and cooling. Ductless mini-split heat pumps are chosen because they take up very little space and do not require the crew to cut additional steel beams or lower the entire ceiling. Each outdoor unit can connect to several indoor units mounted on the wall or ceiling. Only a small electrical cable, a condensation drain line, and 2 copper refrigerant pipes need to pass through the container wall, making the system compact and well-suited for the limited space inside a container home. Once the doors and windows are installed, the steel shell of the house moves into the final finishing stage and is permanently secured to the foundation. The steel surfaces are cleaned with an angle grinder and sanding pads to remove millscale, dirt, and visible rust. The metal is then wiped with mineral spirits to remove oil and grease before primer is applied. Clean bare steel is coated with self-etching primer, while areas that cannot be completely cleaned receive a special primer designed for rusty metal. The remaining joints are sealed with paintable silicone. Roof vent pipes are also protected with flashing, sealant, and an additional waterproof coating to prevent leaks. The outside of the containers is then spray painted with a matte finish. Spraying allows the paint to reach evenly into the corrugated grooves and around welded joints. Inside, white paint is used to reflect more light and make the rooms feel larger. After the paint has fully cured, the crew seals the 6 mm gap between the bottom of the container and the concrete slab. Spray foam is added first as a backing layer. Quikrete grout is then pushed deep into the gap, smoothed and cleaned. The most important step is anchoring the containers to the foundation so they cannot move during an earthquake. The anchors are made from 19 mm thick angle steel, steel plates, and threaded rods. A total of 72 holes, each about 25 millimeters in diameter, are drilled into the steel before the anchor assemblies are welded together by a certified structural welder. At the site, the hole positions are marked on the concrete foundation and drilled about 30 centimeters deep using a hammer drill. High-strength epoxy is injected into each hole, and threaded rods are then inserted and fixed securely inside the concrete. Once the epoxy has hardened, the steel angle brackets are welded directly to the container corner castings. From that point on, each container is no longer simply resting on the concrete. It becomes a permanent part of one unified structural system. After the drywall is finished, the kitchen is installed before the final flooring goes in. Because the container is quite narrow, adding the internal framing and insulation reduces the usable width to just over 2 meters. First, the kitchen cabinets are placed in position to check the locations of electrical outlets and plumbing connections behind them. Cabinets next to each other are screwed together, while shims are added underneath and behind them to make sure the entire cabinet system is level and properly aligned. In the main container, the bathroom is located between the kitchen and the bedroom. Instead of using valuable space for a separate hallway, it is designed as a walk-through area. Once the framing is complete, work begins with the plumbing hidden beneath the floor and behind the walls. After the floor is finished, the toilet, narrow vanity, sink, and faucets are installed. The vanity is fixed directly to the wall, while the water supply lines are connected on site before the drainage system is completed. A mirrored cabinet with sliding storage on both sides is installed above the sink to provide extra storage in the limited space. Once the bathroom is complete, the crew moves on to the 2 bedrooms located at the ends of the containers. Because the rooms are narrow, the entire layout is designed around one main piece of furniture, the bed. Instead of placing a normal bed directly on the floor, both bedrooms use raised bed platforms, turning the space underneath into storage for luggage and other belongings. In the guest bedroom, the raised bed platform is combined with linen curtains and a lowered ceiling built around the concealed air conditioning unit, creating a modern canopy-style sleeping area. The space underneath is large enough to store suitcases, while 2 glass doors positioned opposite each other bring in natural light and allow fresh air to flow through the room. After the drywall is finished, work begins on the kitchen before the final flooring is installed. Because the container is already narrow, adding the timber framing and insulation reduces the usable interior width to just over 2 meters. First, the kitchen cabinets are placed in position temporarily to check the electrical outlets and plumbing connections behind them. Cabinets next to each other are screwed together as one unit. Shims are then added underneath and behind them to make sure all the cabinet fronts are level and perfectly aligned. In the main container, the bathroom is located between the kitchen and the bedroom. Instead of using valuable space for a separate hallway, the bathroom is designed as a walk-through space. Once the framing is complete, construction begins with the plumbing lines hidden beneath the floor and behind the walls. After the floor is finished, the toilet, narrow vanity, sink, and faucets are installed. The vanity is fixed directly to the wall, while the water supply lines can be connected on site before professional plumbers complete the drainage system. A mirrored cabinet with sliding storage on both sides is installed above the sink to make up for the limited storage space. Once the bathroom is complete, the crew moves on to the 2 bedrooms located at the ends of the containers. Because the rooms are very narrow, the entire layout is designed around one main piece of furniture, the bed. Instead of placing a normal bed directly on the floor, both bedrooms use raised bed platforms. The space underneath becomes useful storage for luggage and other belongings. In the guest bedroom, the raised platform is combined with linen curtains and a lowered ceiling built around the concealed air conditioning unit, creating a modern canopy-style sleeping area. The space beneath the bed is large enough to store suitcases, while 2 glass doors positioned opposite each other bring in natural light and allow fresh air to flow directly through the room. From the outside, building a house from shipping containers seems simple. Take an existing steel box, cut a few openings, add the interior, and turn it into a home. That image is why container houses are often described as a fast, affordable, and environmentally friendly way to build. But the reality is much more complicated. The container itself may represent only a small part of the total construction cost. The more steel that is removed to create large open spaces, the more of the container's original strength is lost. As a result, a significant amount of new steel may have to be added for reinforcement. When several containers are joined together to create larger rooms, the building can even begin to behave more like a new steel structure built around the containers, rather than a house made simply from ready-made boxes. The environmental benefits also need to be considered carefully. Reusing an old container can extend the life of steel that has already been produced. But that does not automatically make every container home a green building. Insulation materials, concrete foundations, additional structural steel, transportation distances, and the energy needed for heating and cooling all affect the final environmental impact. On the other hand, shipping containers still offer some clear advantages. They are factory-made to standard dimensions, easy to transport, strong enough to survive harsh conditions, and can be turned into building modules relatively quickly when the design is carefully planned from the beginning. And that is where a shipping container stops being simply a leftover product of the transport industry. It becomes a completely new engineering challenge, combining architecture, structural design, and the reuse of existing materials. Behind the simple appearance of shipping containers are hundreds of details that must be carefully planned. From the concrete foundation on an empty site to layers of reinforcement and utility systems, each step gradually transforms these steel boxes into a complete home. Even though each container offers very limited space, a smart layout can still create a comfortable house with all the essential functions. So in the future, will container homes become a common building solution, or will they remain better suited for special projects and specific sites? Share your thoughts in the comments, and don't forget to subscribe to Mandarin Tech. As we continue exploring the engineering and technology behind the world's most interesting construction projects,